All right, you guys, very exciting times today. We are on the two sample t interval today. So we have flipped the page. We are now on section 10.2, and we are no longer talking proportions. There aren't p's, there aren't percentages or proportions. We are talking now two sample t intervals. And remember from chapter 8 and chapter 9, when do we use this thing called t? We use it when we don't know the sigma for the entire population. I have that down here. That is the same z's, you guys. The same thing as chapter 8 and chapter 9. We have this thing called t. So read through this problem here. A college graduate's trying to decide, should I live in New York or should I live in Chicago? I know you people are probably like Chicago, most of you, because hi, that's where we're from. But we have they're trying to make their decision based on monthly rent. So they have random samples of 10 different apartments in each city. Not sure how they got the random samples, but whatever, it says random, so we're going to go with it. And in New York City, this is monthly rent for the 10 randomly sampled one-bedroom apartments. And in Chicago, here is the 10 randomly sampled apartments from there. And so just eyeballing these two lists, does it kind of look to you like New York might be more expensive overall? We can come up with an average and a standard deviation, and we're going to pop these in the calculator very soon. But it looks maybe like New York might have convincing evidence here that we have more expensive apartments, but I'm not sure. Let's see if there is a difference. We are having a keyword right here, estimate the difference between New York and Chicago. That means do an interval. Notice how it doesn't say, do we have significant evidence of a difference? That's when you write a ho or a ha, okay? And also they're telling me 99% confidence, okay? So that's a big clue key that we're doing an interval here. This chapter has intervals and tests in it. You are watching the video called two sample t interval, but on the chapter 10 test, you need to know that we might have to do an interval, or we might have to do a test that'll be coming tomorrow. And we also did a test yesterday for proportions. But anyways, the mean difference in monthly rents, they're telling us here to subtract New York minus Chicago. That is very important. Based on the cost of living, where should this person choose to live? So we're going to answer this question after we do our interval. A lot of us forget to answer the follow-up questions, so just be careful about that. I am going to roll right into this thing. The first thing we do is we define the stuff. Excuse me. So all of these are X values. They represent, it's a dollar amount of monthly rent for one-bedroom apartments in New York, and this is where the sample was taken from. This is the population, one-bedroom apartments in New York. Same thing, these values down here are X values. They represent dollar amounts of monthly rent in Chicago. So those are our two different X values. And notice I'm using an N for New York and I'm using a C for Chicago. You can use A's and B's. You can use 1s and 2s if you want. I think it's easier to use an N for New York and C for Chicago. Just name your variables and then you just have to define them, whatever they are, okay? We are doing a two sample T 99% confidence interval, 99 because that was given in the question, and it is a T interval because we don't know the sigma from the population. It would be impossible to have every single rented one bedroom apartment for rent in New York City, so we don't know the sigma for the entire population. We only have 10 from New York, 10 from Chicago. Let's see what our conditions look like here. Yes, I'm going to eventually type these into the calculator, so hey, if I go too fast, pause the video and catch yourself up. But random, we did take a random sample. It does say two independent random samples. We have two random samples, one from New York and one from Chicago. Okay, great. Independent condition, there are definitely more than 100 apartments in each sample, or in each population, in each city. How did I get 100? I took 10 and multiplied by the sample size. And I just wrote each city here instead of doing two of them because they're 10 for each. So the sample size is the same for both. So I think it's okay to just do it once here for the independent, making sure that I am mentioning that I'm applying that to both cities. Normal condition, we do NP and N1 minus P, right? Nope, because we don't have P's. What do we do for normality? Step 1, does it say that anywhere up here that we have a normally distributed, a normal distribution? It does not. Step 2, can we apply the CLT? Please, 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 no. We only have 10 from here and 10 from here, so CLT doesn't apply. Dang it, we have to sketch a dot plot of these things, okay? This is Option 3 for the normal condition. And for this problem, I'm just going to give you, you can copy this into your notes really quick if you want. I am just going to give you the box plots, but you could also very easily do a dot plot. And all you do is you label your x-axis and you put 10 dots for the 10 apartments in New York City, and you put 10 dots for the 10 apartments in Chicago, and you are just checking for two things. Does it look strongly skewed, or do you see any outliers? Okay, in this case, looking at the box plots, this one looks almost beautifully symmetric, right? It's a little tiny bit skewed, but whatever. This one is skewed a little bit more, but I wouldn't call it extreme. Okay, if I want you to mention something extreme, it's going to be like, it's going to make you look at it and go, whoa, that looks weird. Okay, they're never going to be perfectly symmetric, but it's also not extremely skewed. And we definitely don't have any outliers because we don't have any asterisks for either of those. So that means, my friends and family, that it is safe to use T. Anyways, okay, where am I? Can you pop these into list 1 and list 2 in your calculator? Use New York for list 1 and use Chicago for list 2, since we are subtracting New York minus Chicago. That's the way to put it in your calculator. New York first, Chicago second. And then you can pause the video and catch yourself up, and let's make sure that you agree with all of these stats here. So I'm going to erase them so that you can see. It looks like the sample mean of those 10 apartments in New York is 2025. Looks like for Chicago, it's 1588. That seems like it's a significant difference to me. Almost a $500 difference, right? That seems like it's a big deal, but we don't know statistically if it is or not. There's my standard deviations you can see, and I'm labeling, like, notice my subscripts here. I'm labeling N for New York, and I'm labeling C for Chicago, so it's clear. Degrees of freedom. 10 minus 1 equals 9. Can you make a note about this? I believe it's in your reading guide, but your degrees of freedom, you guys, what if your sample size is different? You use the smaller n minus 1. In this case, they're both 10, so it's 10 minus 1, which is 9. But how do you know if you have two different sample sizes? Make sure that your group members are okay with that, all right? Anyways, and how do I find the T star? Because that is part of the confidence interval formula. If you forgot inverse T, you do need the degrees of freedom. And this 0.005, that is a 0.5% on each tail when you put 99 in the middle. Okay, remember that? Gives you this for the T star. So anyways, now let's plug in our numbers. Let me write what it is in words, and this is from the formula sheet, if you remember this. Statistic plus or minus critical value times standard error of statistic. Sorry, it says error on the formula sheet now, so I'm going to change that. The statistic is the difference between New York and Chicago. So what does that look like? I'm taking my X bar, and I'm subtracting my other X bar. Okay, New York minus Chicago. They're telling me to do New York minus Chicago, so I'm doing New York minus Chicago, okay? That is my statistic right there. The direction is important, and that needs to be specified within the problem, okay? The critical value, I got that right here, 3.25, so that goes in next. And the standard error of the statistic, wowza. Let me go back to the formula sheet really quick just to point this out. So we are now on means, friends and family. So we were talking proportions the last couple days. Now we are on means right here. And I have two populations because one's from New York, one is from Chicago. There's my statistic. And what I'm using here is my sample standard deviations. I don't know the sigmas, right? So I can't use those. But I'm doing the sample standard deviation squared and dividing them by the sample sizes. So this is what I'm going to be using for the standard error of the statistic. Okay, it's right there on the formula sheet. Make sure you know where to find it. Where is it and how can I show this? So I have those two standard deviations of the samples. Those are from right here. I got them from the calculator. Those go in. Sample size is 10 for both of them. Let me erase this whole thing now. There's my interval. You can type this whole thing into the home screen, but that would kind of suck. So how are we going to type this in? Friends and family, make sure that your group members understand where to find 2samp t int. And here's what's weird is when you click on 2samp t int in the calculator, it asks you a weird question. Okay? It says, do you have the statistics or do you have the data? Okay? In this problem, we have both. Data means do you have like the list of information here? Which we do. You already typed New York into list 1 and Chicago into list 2. So when you hit data, tell it to use list 1 and list 2. Okay? What does it mean if it asks for stat? Sometimes you can like type in this information, which we have. So you could also type in the statistics, meaning I have the X bar, the other X bar, the standard deviation. I have all of that information. That is what you have to type in if you hit stat. But it's a little bit easier in this case. It's less typing if you just do data and then tell it to use list 1 and list 2. So that is something that's weird, but actually open up your calculator and you'll understand what I'm talking about, okay? What does this interval tell us, you guys? This is negative and this is positive. So we are estimating that the difference between New York and Chicago could be negative and could be positive. We don't know. Could be 0. We're not sure. Okay, that actually gives us some valuable information. How do we write our conclusion? We are 99% confident that blah, 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 I'm indicating the direction of my subtraction, is between negative $77 and positive $951. Since 0 is included, that tells us that I'm actually not super confident there is a difference. Okay, statistically, there is not a difference. Remember when we calculated these stats and I literally said, wow, it looks like New York is more expensive than Chicago. But statistically, it's not considered a significant difference because our interval is estimating that if we would take different samples, maybe it would be a negative difference, maybe it would be a positive difference, maybe it would be 0. Okay, that is useful information. Keep in mind, if our entire interval was positive, what would that tell us? That would tell us more expensive in New York. If our entire interval was negative, that would tell us more expensive in Chicago. Okay, but our interval is both positive and negative. That means, friends and family, how do we answer that final question? Where should this person live? Wherever it makes their heart happy. Okay. That's the conclusion of this. Let me know if you have any questions. Please make sure you're okay in the calculator because it's kind of weird when it asks you data and stats. Data means do you have all of the actual data values? Stats means do you have this information? Okay. Now I challenge you to try the next problem in your groups and please let me check it to make sure you're good. Okay. Love you guys.